So hello everyone, welcome to the panel B of environment. I want to present our moderators, Eren Geiger from the Umweltcluster Bayern. He's Referent Bioökonomie and Project Manager at the Umweltcluster Bayern. And he will start with the panel. Then we will have Sören Metz from the TUM Sao Paulo. He's manager at the TUM Sao Paulo. So let's start with the panel. Welcome everyone.
Thank you, Aura. First, before we start, I think Sören will give you some information about the chat that we manage your questions. That is important, I think.
Yeah, thank you very much, Marco, and thank you very much, Aura, for the invitation. As we already did in our panel A about environment, so now we're on panel B. So you see when you're on the platform, this session, there's a chat function, and I already posted some comments in there. And yeah, please post your questions directly there. I will have a look on the questions. I will give them to the panelists. And yeah, if you have any other questions, technical duties and anything, just post it there and we are looking for the questions. And yeah, thank you all for being here. And now heading over to Marco.
Yes, thank you, Sören. As Sören told us, we already managed the panel A, so now we're starting the panel B about environment again, but we will have something, a new focus, and we'll start with input from Sweden. So Jan-Olof Drangert, a professor from the University Linköping, will tell us something about the security part of urban water and food security, and how resource smart cities can also use residents, I think. So I got some information that you're not only professor, you're also trainer in the environmental field. So I'm very happy to hear something about that. Thank you. It's your part. You can start.
Thank you very much for inviting me to this important meeting. My topic is about urban water and food security and how we can use both smart cities and resource smart residents. And next, Aura, next please. I'm focusing on why bother about food and global environmental issues. I look more detail into diets and food chain waste, including the excreta, since these are critical issues. And also I look at methods to guide us to create a circular flow of both organic waste as well as water. Next. Now, for the first time in history, actually, we have to bother about global issues. And I'll give you one reason or explanation why we have to consider this. If you look at the globe in the daytime, it looks blue, green, and very habitable. And if you look at the globe in the nighttime, next, yeah, then you can see that much of the globe is actually lit. And that means that each and every one, when we use light, it can be seen also from the sky. And that means that collectively, our activities become very visible. And if you see the thin layer of the atmosphere here, that is going to take on all the carbon dioxide that is produced while lighting all these lights along in Japan and other countries here. So it's no question that we can collectively really have an impact on the global climate. And this is part of the what is being discussed now in Glasgow. Next. Now, if I focus on food production for a short while and look at its impacts on the environment or nature generally, next, you can see that the greenhouse gases, next, about 1/4 of the greenhouse gases are connected to food production, and the rest is from industry, transport, etc. So food production has a visible impact on the emissions. Next. As for the freshwater, next, we can see that the food production have an even greater impact on eutrophication. Some 70% of the eutrophication is rising due to food production. Next. And for the eutrophication, 70% is used of the water, fresh water is used in food production. And then about 78% is actually used causing the eutrophication of the lakes and rivers. And next. For the biodiversity, it's even worse, that 94% of the biodiversity loss can be attributed to food production activities. Next. Now, if we look at the habitable area, about half the globe is habitable, and 50% of this is used for food production. Next. And if we look at the kind of food production that is taking place in these areas, the plant-based diet is utilizing a small part of the habitable area. Next. Whereas the animal production constitutes 4/5 of the food production area. Still, it's only 37% of the now it disappeared for me. 37% is for the protein production, and 18% of the 18 calories that we actually get from the food. Whereas plant production provides us with 63% of the consumed proteins and 82% of the calories, rather opposite to what we think, that we get most of the proteins through animal production. Now, we see here that animal production is very dominant in the production. And if we can minimize that, it will also have a lot of impact on the other 4 aspects that we've looked into, with freshwater use, biodiversity, etc. So let's take an example that we reduce the animal-based diet production to 1/3 only. Next. Now I can't see it. Yeah, there it is. Then the animal production area is reduced to this much, but since we produce less protein and calories with that, we have to extend the plant production a bit. So, but in total, it's almost half of the previous area that is used to produce the same amount of proteins and calories for the diets we have eaten. Now, that means that we can actually improve the environment impact quite a bit simply by changing diet. And we have already started that. If you take the case of butter, in many countries we have switched over to vegetable margarine. As for milk, we're now changing it to soya drinks, etc., also from vegetables. And of late, we see that they try to change the meat into veg burgers, etc. So it's not a question of shifting necessarily from vegetarian diets to meat or animal-based diets. It's more of, we can convert the vegetable thing into something that is very similar to the meat or animal-based food. So the shift from from an animal-based diet to a plant-based diet is not that dramatic for the consumer and us as eaters. Next. So let me give you an idea of how much food we require over time and how much nutrients we dispose of in excreta and food waste, etc. This is a graph of the population from the year 1500 up till today. And we can see that only in last century, the population increased rapidly. Next. And we can read this graph as the number of people, but we could also say that it represents the amount of food eaten in the year 2000. Next. And then we can see that we ate about 3 times as much in the year 2000 as we did in the year 1900. Next, if we go further, we can say that in the 20th century, this is the total amount of excreta, for instance, that we produced. And next, we can see that it equals what we produced in the previous 4 centuries. Looking ahead then, we know that we'll reach or above 10 billion people in the middle of the century. Next. And we also know that there is a difference, expansion of urban areas and a decrease in rural population. Next. 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 And if we see how much, for instance, excreta that was produced in urban areas in the 20th century, it's this yellow one. Next, and if we compare that with what will be produced in this century, it's an increase about 5-fold. That means that if we rob all the nutrients, put it into food and discharge it into lakes and rivers, we lose a lot of nutrients, and we have to bring them back to the agriculture. Otherwise, we'll starve of phosphorus, potassium, etc. Next. So how can we do that? Well, there are several ways of constructing eco-houses. This is an example from Kathmandu, where Roshan built his house to be self-sufficient when it comes to energy, water, and partly for the food. Next. Next. Now you can run through this. You collect the rain, of course, and put the rainwater into tanks in the basement. Next. Aha, they fall outside. Okay, go on, show them. You can continue pressing the button. So what you do is that you collect the energy from the sun, the rainwater, and together with the groundwater, you can actually feed this family without importing any water from the outside. You can also make sure that you don't discharge wastewater outside of the plot. Next. In a more urbanized area, this is from Milan in Italy, where they have built 27-story buildings, where the trees and bushes here are grown on the big balconies, and here they will serve essentially as carbon dioxide taking up sinks, and also you may have some fruits and the vegetables grown here. So as for the discharges from the toilets and so on, you can collect that and convert it into pellets and use it as fertilizers in surrounding agriculture. Next. Next. So in figures, then you can collect a number of statistics. In Sweden, for instance, we have a per capita consumption of 140 liters per person per day. It's for mainly for hygiene and shower, 60 liters, toilet flush 13, washing clothes 15, washing dishes 15, food and drink 10, and others 10 liters. Now, by simply changing to water saving showers, dry or low flush toilets, etc., you can actually reduce the consumption down to 70 liters per person per day without any loss of comfort. Then this is for the reduced part of what you can do. As for the reuse and recycling part, you can reuse some of the grey water, for instance, if you want to flush the toilets with treated grey water, that is quite okay. Whereas the black water is rather difficult to reuse and also to recycle. But grey water can be recycled for washing machines, etc. And if you do that, you can reduce further the need or demand for water down to perhaps 20 or 30 liters per person per day. And that's a dramatic change compared to the present one of 160 in Sweden, 200, 300 in the US, etc. Likewise, you can, with rather simple measures, reduce the or recycle the nutrients in the food, etc. And we have made an example here of what you can do with the phosphorus, and you can actually, in the end, replace some 70% of the presently imported phosphorus in fertilizers with fertilizers from recycled nutrients in urban areas. So it's a dramatic change and possibility for us to lower the pressure on natural resources. Next. And the simple principle is, next, simply not to mix a lot of flows. And now you can go ahead. You don't mix organic and solid waste, of course. You don't mix stormwater and sewage water. You don't mix, next, industrial and household water. And the new thing is that you don't mix black water from the toilet with the grey water. If you do that, then you have the nutrient-rich toilet water separately becoming fertilizers, whereas the chemical-laden grey water has to be treated in another way and cannot have that kind of reuse. Next. And in some cases, it may also be favorable to keep urine and feces separate. But the black water is the main source, together with food waste, to make urban fertilizers. Next. And how is that going to be achieved? Well, if you look 100 years back, we changed our cities totally in order to accommodate the vehicles. And with 80 passengers in one car each, it will look like this in our streets. Next. If you replace it with motorcycles or pedestrians, then you occupy this much of the street. And likewise, if you use public transport instead, you can bring all these people into the bus. Now, if you compare the left and the right here, you realize that you have a lot of free space all of a sudden. Parking places, streets, etc., that can be converted into green areas. Next. And it may look like this instead, where you can actually both produce some food and recycle some of the nutrients and water that comes out of our houses. Next. Next. So, in conclusion, recycling amplifies the global and local resource base and reduces pollution. Both are essential. Limited natural resources can be made almost limitless by being recycled. Each and every one of us can and must contribute and facilitate recovery by not mixing different waste categories. We have to be much more clever than that. First, mixing it and then trying to disentangle it. And we should start now, not tomorrow, because at present we're building all these houses. In this century, we're building 3 times as many houses as there were in the year 2000. So if we build it now, we can choose whatever direction we want to take. But in 50 years, we've already built so much so that then you have to rebuild it and it becomes terribly expensive. Next. So I think that is great prospect of changing our ways of using water and nutrients without lowering the comfort as urban residents. Thank you very much.
Thank you, Mr. Drangert. I think Sören has 2 questions directly out of.
Yeah, we have a question from Jose. How well is being adopted vertical farming in government public policies? If you could elaborate on that.
Well, I would say like this. If you go 130 years back, then there was a discussion similar to the one we had now in France and in other countries that we know a bit more about the history. And I mean, in Asia, they have always recycled the excreta. So I think that when it comes to governments today, the problem is that, one, if you have dry systems, they think it is fresh feces that individuals are going to deal with. And that is very disgusting. So it will never take place. And no one has actually suggested that. We always talk about treated excreta, dried, etc. That is soil-like. Secondly, I think they haven't reached the consciousness yet of the lack of nutrients that we're going to have for the centuries to come. And by simply investing in a separate pipe for the toilet water all the way to the treatment plant, then you can easily convert this into a fertilizer. And it's the best fertilizer. It doesn't contain any heavy metals apart from the natural level, etc. So I think that up till today, EU, for instance, they treat excreta very strangely. They have no policy for excreta per se, but only for excreta mixed with water and grey water. Then they talk about how to recycle the sludge, etc. But similarly to what happened to the drainage water from rain, I think that the first pipes we had went together with all the sewage. Then we realized that in a heavy rainfall, then you have overflow of fecal matter in the streets. So you can't mix them. So you start separating them in new cities. And I think the next step in this process will be the simple one, to keep the toilet water separate and the grey water separate. Both
maybe as we are a little bit short on time, Mr. Drangert, I would just give you, because you were and we love that you have a lot of knowledge and a lot of experience, but giving Maria wants to know, is it actually realistic to think that people could go back to growing their own vegetables? considering all the time and effort this requires when you speak about vertical?
I think that is a good question, really, because what we have is that in a number of cities in the world, in Moscow and other places, they have produced more than half of their food within the city limits up to the end of last century. So they have changed away from greening the cities. Now you have the counter activities going on in a number of cities in Italy, as I showed here, in Singapore, in New York, where they start looking at empty places, including flat roofs, which can be used for food production. And in a number of cities in Sweden, we have now these not only cultivation on the rooftops, but we have cultivation within small greenhouses that use minimal amount of water and recycling all the nutrients within the house. So
and not to interrupt you, but maybe because I think you already answered that. Maybe just for one little component here is it affordable, or how could this be affordable to redesign the houses when you speak of refurbishing actions for being sustainable and for being like to including vertical gardenings and all the aspects you already mentioned. Maybe like a short answer, just how to do this, and then
if you build the house from the beginning, the piping will cost almost nothing. It's an extra pipe only in the house. It may be $100 US for the whole house. But if you have to refit it, then of course you have to wait until you refit the whole water system in your house. And that is being done every 50, 60, or 70 years. And that's why I emphasize that start with the new houses where it costs nothing to add these pipes. Don't wait, build them first and then refurbish the whole thing.
I think these are excellent last words, and I hand over to Marco. Thanks a lot, Mr. Drangert, for your presentation, and Marco will continue. Thank you.
Thanks.
Thank you, Sören. Thank you, Mr. Drangert. I think the next part, this presentation 2 of our panel from Melissa Sanchez, will go into the same row. So we will have now more the focus on how to prevent flood damages, flood hazards with mapping them, and to help local decisions to prevent it. So Melissa Sanchez was born in Colombia, and I think she had also some, she got some impressions out of the folia from Mr. Drangert out of Munich, because you lived there a time. And yes, we're happy to have you here. You can start.
Thank you very much, Mr. Geiger. First, I will ask for put all the micro off, now that we have interruptions after. Yeah, as Mr. Geiger said, I'm from Ibagué, from Colombia, and I'm very happy to be here also to share this experience that I have in Germany. Maybe also a bit interesting. I've been living in Germany since 11 years, and I've been working a lot also with this topic of floodings. And yeah, I'm happy to show you the topic today. So the name of topic is flood polders, supporting the prevention of flood damage along the Rhine River. So a bit about the contents. First, I'm going to go from the global to the more specific topics. First, I'm going to talk in general about flood polders and what is the relationship with hydronumerical models. After, we will go through the flood retention areas in Rhineland-Palatinate, but it's actually the whole flood retention areas in the River Rhine, the Upper Rhine. And I want to focus after in one of these flood retention areas of these flood polders, which the name of it is Hörde, is the Rhine floodplain. And I will tell you a bit more specifically about the challenges of planning and interdisciplinarity of this project. Okay, more about the organization. I think I will be talking 15 minutes and then 5 minutes of questions. And yeah, so this is them. I think I have to move that here. What is actually flood polders and what are hydronumerical models? That sounds everything a bit too complicated. I'm a modeler, actually. I do hydronumerical models. And that's the reason why I really like to talk about it. So I want to tell you a bit more what is a flood polder, because I know that there are people here from many areas that maybe might not know what it is. I will begin saying that this is the river Rhine. It's a very long and important river. And a flood polder, you have to imagine that is more or less like a swimming pool that is here next to the river Rhine. And this, let's call it swimming pool, this flood polder will take a volume of the river Rhine in it. It means when there is a flood in the Rhine, where the water level of the Rhine rise at a particular point, the whole water volume of the polder will be full. This polder will be full of water, and of course, this volume won't be anymore in the river Rhine. And it's a measure of control for the flooding. So, what is actually hydronumerical models? We in the mathematical, I'm environmental engineer, and this is why I studied. We have different methods to model that in the computer. So it's actually only about, we see in the computer what's going to happen in a flooding, and we have predictions of water level, of volume, of how many cubic meters per second are in the rivers itself. So this topic is about flood management, of course, but it's also have to do with hydraulic structures. We have to see which are the dikes of the river Rhine, which are the like all the structures that itself have the river Rhine, also the shipping structures. It's also about decision making. Of course, we are talking about people, what's going to be done, and also it's about renaturation, because of course when a river is being built, with something in the river is being built, so they take advantage to renaturate it, to make it pretty for the people also. So the second part is oh, sorry, I didn't say before that I'm going to focus the next slide. It will be in this area in the Upper Rhine, that is Baden-Württemberg and the Rhine-Palatinate. There are two departments of Germany. So this is here Baden-Württemberg, here's Rhine-Palatinate. And these are the 12 flood retention areas that are now being used in the river Rhine. Well, actually, these two marked in colors, they are being built from now. They are not being, they will be open in the next years. And sorry that this is in German, but this is all about names. So there are, as you see, there are many polders all around along the river Rhine, and every polder have a capacity in cubic meters, and this is what it says here. And I want to tell you more specifically about this polder here. I've been working with this polder, and I've been part of the group who is planning it. That's why I want to talk about that. And as you see, is the biggest polder, is the polder with the biggest volume itself. When it will be done, it will have the capacity of 32 million of cubic meters. So this is how it looks. More in the focus. This is a current state. As you see, there is not really much in there. These are long arms, long and old arms of the River Rhine. And this is what is going to be done. So something also very interesting that I learned in Germany was that the River Rhine was not straight as it is right now. That was a project many years ago who dreamed about shipping, about doing transport in the River Rhine. And that was the reason why the River Rhine was being built straight. But in the past, the River Rhine have many meanders in here. And this is still like a part of the history that's still there. The River Rhine right now is only straight, but the old arms of the River Rhine can still be seen. So this floodplain or flood retention area is also focused to anyhow use these old arms of the River Rhine. And it have two parts. The first part of the flood retention area is the flood retention area itself, that is all this area in here. And it is rounded by this dam that is in the pink line. And the ecological flooding, it is inside this flood retention area that is it would be the line red and white. I want to do something in here for a second. I think that the colors might be strange before. So, and this ecological flooding part area, why is it called like this? The story is that the animals itself and plants that are in this zone were already in the past get used to the flooding itself. They knew, okay, it come a flood, and well, they were anyhow get used to it. And this ecological flooding part, it's the aim of this part is that the animals and plants get used again to the flood. And for this reason, this ecological part of the whole retention area should be flooded the most of the time, most of the days of the year. And this is the main purpose of this area. That means the water will be taken from the River Rhine, comes here through from the south and flows to the north part. And in this trajectory, it should flood itself also in the area. Reason why you see also a flood area in here. What is the second part? What is the flood retention itself? When there is flooding in the Rhine, when there is a really big flood, the water of the Rhine will come until here, not only here in the channel itself, but it will come after, and it will reach the dam of the River Rhine. In this dam, the water will flow through these three parts, this 1, 2, 3, will flow very fast into the flood retention area, and it will be very fast filled in with this 32 millions of cubic meter of water that I mentioned before. So I go in. Something very interesting. What are the challenges of the planning? Why is it so hard to do that? Actually, it's a project that have been done already 10 years, and I think it will take another at least 5. And why is it that so long? This actually has something to do with the challenges of the planning itself. The first one that I want to mention is the land use. And why is the land use here so important? For example, because there are agricultural zones in here. You see more or less here that there are crops. And of course, we cannot touch these agricultural zones, or we have to talk about that. Of course, no one is happy if it will be said, okay, can we use this area for flooding? Because after you won't be able to have any crop in there. Second, of the land uses, that all the zones in brown and blue are flora and fauna protection areas. That means it's very important that we have to take care about the animals and plants who live in there. Second challenge is the velocity of the water itself. So as I mentioned, this area should be flooded more or less 200 days per year. And because of that, we are saying, okay, this the main purpose hydraulic, if we see hydraulic, should be flooding of a very big area. But at the same time, the water is not allowed to be stagnant, because it's not allowed to be stay. It must move in the area. What happens if the water stay? We will have problems with oxygen, and of course this is very dangerous. But at the same time, there is another purpose, is this readjustment of flora and fauna to the flood. That means it should go fast enough that it creates a big flooding area, but it should go not that fast that kills the animals and the plants. And another challenge is also that there is as much as no slope in this area. It's a very plain area, and there are many problems with erosion in general in the river Rhine. So you see there are like parameters who are like go fast but not that fast, protect the animals but try to also think about the hydraulic. What are the challenges of the whole retention area itself? It takes, of course, a volume from the river Rhine, and the shipping are very or it's not only the retention area but also the ecological area. The shipping area is, of course, thinking about that, like, are we going to be able to ship all the year, or are you taking too much water from the Rhine so that we are not going to be able to ship? And that's very important, of course. There are many cities near to this area. I don't know if you can see it here around. And these cities are sometimes 100 meters away from this retention area. And it's very important, for example, to think about the groundwater issues. Of course, if there is a flood here, if there is a, as I call it, there is a pool of water, of millions of cubic meters of water, you have to also think that the earth itself, that this water might filtrate itself in the earth. And this is what about this is what groundwater means. And of course, it have to be controlled to avoid further floodings in other areas that we are not aiming to flood. Another very important topic is a dam break. What would happen if, for example, this pink line, this dam breaks, or if the dam of the ecological zone breaks? And these are very important topics, very important issues that we have to consider. In my last slide, I would like to say that this is a very interdisciplinary work. I'm very happy to work with people who are, for example, have to do with hydrology, because there are these old catchment areas are flowing in the river Rhine. So you don't have to consider this zone, this is the zone I was talking about, alone, but you also have to consider it as a part of a system, of a hydrological system. We also, of course, have to talk about flood control itself. All of the measurements that were already done. For example, here are the dams in the river Rhine, and the areas that have been done have been flooded for the last years when it happened. Or one also very interesting topic is the nature reserve and the protected landscapes that, as I mentioned before, are also a topic who is being considered most of the time for environmental planners. Or, for example, something very interesting is the surveying and remote sensing. Why do we know that this zone is a flat area? Because it was a remote sensing done before. Maybe you can see here that there is like a flat area. This is a flat area, sorry, in this part. Yeah, and this is the quite interesting topic. You see the complexity, but also how big it could help for the flood protection areas. That's from my side, and I'm very happy to answer the questions.
Thank you, Melissa Sanchez. I think Sören collected some questions, otherwise he will tell us.
Now, we don't have any questions so far, but maybe we just jump in with Dora, and then we will have, because at the end of the session, we will have this bigger Q&A session. And oh, there is one from Juan, as I was speaking. Melissa, and this is related to you. In flat regions, is it possible to find several spots where they may be a potential flood? What key factors are taken into consideration to prioritize them?
I think I didn't understand the question. In regions where there are floods?
Now, in flat regions, is it possible to find several? In flat regions, is it possible to find several spots where they may be a potential flood? In flat regions, is it possible? Well, Marco just posted it here.
Yeah.
I don't know if the questions is being.
Okay.
If this is the question.
Now I can read it. Of course, in flat regions, there is always flood. It was even a joke when I was living in Cali, because I study near to there. In flood regions, there are floods. In mountains, no. I came from the mountains. That's the reason why it was like a joke in that time. And of course, if it's flood, it always the water stays. If there is a mountain, the water go out. They have another problems, but of course, it's when it's a flat regions, there is always floodings. And what are the main the key factors to take into considerations? First and all, we always work with a survey. We always work with satellite data, because we need to know what is the terrain. If I don't know how flat is the flat, then I don't really can go further. So that's maybe one of the key one of the key topics. The second one is there people in there, and which people are in there? And this is also a very important topic. If there is no people, so it's not important. Well, maybe there will come the environmental planners and tell me that's very important. But as I said, it depends who is analyzing the area. It might be different topics and different factors who are taken into account, different variables. Of course, the most important for us, I'm very near to the hydraulics, and the most important for us is of course the river. It's not the same when we are talking about the Rhine, which has in the moment have 800 cubic meters per second. It's a huge river. Than when we are talking about a small river, or even a river that only can be formed when it's raining. So of course that's also very important.
Yeah, thank you. I think Marco, if you want to continue, because I think this was the only question, and then other questions for you, Melissa, can come up in the joint Q&A session afterwards.
Mm-hmm.
So we do so, Sören, I think. Okay, thank you again, Melissa. And now we will go to the last presentation, and after that we will have a discussion round again with you all. So now it's the turn of Dora Schulze. She's the head of department of 2 rural districts around the lake Starnsee. It's next to Munich that you can locate it, but she's speaking perfectly Spanish. So I think it will be now Spanish, and afterwards we will do a round together again. So if you're ready, you can share the slides for us, or do you have already? They will come.
Yes.
So
thank you. You can hear me. Thank you,
yes.
Mr. Geiger. And thank you for Jan-Olof and Melissa for giving very, very good examples for my presentation, because I am going to explain a little bit about the goals that we have and if we are on the right way. So I am going to make some questions about it, but I don't speak so very good English, so I am going to change into Spanish. I hope it's not a problem. Yes. Bueno, muchísimas gracias también ahora, Lucía, por haberme invitado. Entonces, cambio al español. Retos del cambio climático, adaptación y resiliencia en la gestión del agua en Baviera. Tú vas a presentar las láminas, me dijiste. El agua nos va a acompañar siempre. Tenemos aquí una lámina de Medellín, lo que nos explicaba Melissa, la parte de abajo es plana y a las laderas derecha e izquierda perfectamente perpendicular. Entonces, esa nube que está ahí arriba nos muestra, lloverá después de una sequía o volverá a llover otra vez, nos vamos a ahogar. ¿Qué hay en esa nube? ¿Qué significa ese cambio climático? ¿Qué va a haber? ¿Qué energía hay ahí? ¿Qué va a pasar? Eso es lo que quiero discutir con ustedes aquí. Por favor, la próxima. Ahora tú ibas a cambiar mis... Eso, perfecto. Entonces, les voy a hablar sobre la organización. Primero, es importante entender cómo estamos organizados en la gestión del agua en Baviera. Luego, una corta imagen de los impactos del cambio climático, que esos son mundiales, claro, no son solo en Baviera, sino mundiales. La adaptación de las metas y también qué entiendo yo realmente o qué entendemos en general sobre qué es la resiliencia en la gestión del agua, porque no hay metas, la meta siempre tiene que tener en cuenta a dónde quiero llegar y qué significa resiliencia en un sistema. La próxima, por favor. Entonces, lo más importante en Baviera, porque estamos aquí representando este estado de Baviera, uno de los estados de Alemania, es la organización estricta de nuestra administración. Todas las personas que trabajan en esta organización, desde el Ministerio del Medio Ambiente hasta las oficinas regionales, digamos, abajo a la izquierda, en una de esas trabajo yo, no son puestos políticos. Somos 3.000 personas que trabajamos en ese estado solamente para el agua. El agua, sean aguas lluvias, sean subsuelos, sean aguas para tomar, lo que sea. O sea, tenemos una organización estricta, y que no cambia si cambia el gobierno. Eso nos ayuda mucho a seguir las metas y a poder adaptarlas de acuerdo a las necesidades, claro. Entonces, cambiemos nuevamente la lámina. No, toca cambiarlas a mí también porque están en inglés, espérate. Esta presentación.
Who's sharing the slides? 1 second, Dora. Are you?
Sí.
You can go up.
Es que no las es.
And then on view, you can change it to full screen. Up and left side, there's view. And then you can go to full screen.
Yes, but these are not my slides, are the slides from Aura Lucy.
David is sharing the screen. I can try to share it if you want, David.
No, otherwise it's okay, I think.
Yes, but I need them on Spanish. So you see them in English, but I need it on Spanish. I have another computer, so I'm looking for both.
It's okay.
Entonces, los impactos del cambio climático es realmente, como ya habían hablado también Olof y Melissa, en la incrementación de las lluvias. La incrementación de las lluvias que cambian no solamente la cantidad, sino también la época. Nos están cambiando también la estación. Está lloviendo más en verano y está cayendo menos nieve en invierno. Entonces, el verano es más largo, la época de lluvia se alarga, pero a cambio de eso nos cae menos nieve y la precipitación de la nieve es muy importante, digamos, para que se mejore también los acuíferos, para regenerar los acuíferos. Tenemos la incrementación de torrentes espontáneos o repentinos, no sé cómo se digan esos en español, pero son las Sturzfluten. Y también Melissa estaba hablando de eso, que son importantes, claro, y son una apariencia que se conoce del trópico, que al mediodía de pronto el cielo se abre y se descarga en un punto. Eso es un fenómeno que estamos viendo en Europa y especialmente nosotros que estamos cerca de los Alpes, que estamos creando inundaciones, están creando inundaciones en sitios donde no hay ríos, donde no hay torrentes. Bueno, se cambió la presentación. También tenemos los cambios de los periodos de lluvia, como había dicho, y tenemos uno de los problemas más grandes del cambio climático, aunque siempre hablamos de lluvias y de crecientes y de inundación, el reto más grande es la sequía. En Baviera no estamos acostumbrados a no tener agua, pero en los últimos años en el norte no tenemos agua potable. Tenemos que exportar el agua del sur hacia el norte porque no alcanza el agua para agua potable. Además, no estamos acostumbrados tampoco a que haya riego en los campos. Siempre ha habido suficiente lluvia. En las épocas de verano fuerte, tenemos que buscar nuevos métodos para cómo podemos irrigar los cultivos, porque esos también son cosas nuevas de cambio climático. Pero yo quiero con la próxima lámina mostrarles que no solamente el cambio climático nos obliga a cambiar las metas y adaptar las metas de la gestión del agua. Esta lámina les muestra, digamos, una época en que estaba empezando con la industrialización. Entonces, el método era los ríos había que canalizarlos, ganar más terreno para la agricultura, para la ganadería, ¿sí? En esa época, esa meta era perfecta. La gente, el pueblo después de la guerra tenía hambre. No había transporte por carretera, se necesitaba canalizar los ríos para poder transportar la madera, para poder transportar diferentes cosas. Entonces, esa meta de esa época en la gestión del agua era muy importante. Pero hoy en día decimos, no, esa meta era buena en esa época, ahora estamos retrocediendo. No necesitamos tantas áreas, no queremos tanta ganadería porque la ganadería también contamina, como contaba Jan-Olof, contaba también que la agricultura también contamina el ambiente. Entonces estamos retrocediendo un poquito, pero ¿hasta dónde retroceder? La próxima lámina, por favor. Ok, bueno. Bueno, no importa. Quería otra lámina, pero no importa. Pongamos esta, digamos, hasta dónde retroceder. Esta laminita les muestra un Stehaufmännchen. Este muñequito, siempre que lo volteas, lo acuestas, lo pones adelante, a la derecha o a la izquierda, siempre se empieza a moverse y al final queda exactamente en la mitad. Es resiliente en su forma como se para. ¿Y hacia dónde vamos a volver con nuestro paisaje completamente dañado? El río canalizado, las áreas inundables ya no están, los humedales están secos. ¿Podemos lograr llegar a la parte perpendicular de este muñequito? ¿O será que la meta es más bien hacia la izquierda o un poquito más a la derecha? O sea, la resiliencia ya no es el sistema del momento en que empezó el mundo o de la época de los dinosaurios o de la edad de piedra o cuando empezó el hombre, sino cuál es el punto de la resiliencia. ¿Cómo debe recuperarse el sistema? ¿Hasta qué punto? No vamos a lograr hoy nunca que el sistema se recupere de tal forma que quede exactamente como fue en algún punto, o tenemos que definir ese punto. No sé si es fácil de entender eso. Por eso toca estar pensando constantemente qué es resiliencia, hacia dónde quiero que el sistema se pueda recuperar y qué metas necesito o qué metas quiero seguir para que ese sistema, y qué tengo que hacer para que ese sistema se recupere hasta el punto que yo quiera, porque no voy a lograr mejorar un río o mejorar un cauce habiendo una ciudad a la derecha y a la izquierda. No puedo mejorar el río Cali en la mitad de Cali porque no hay campo. Entonces, ¿qué es resiliente el río Cali en la mitad de Cali? Esa es una pregunta muy importante antes de hacer cualquier plan, antes de darse cualquier meta. La meta no puede decir, vamos a recuperar el río Cali, lo vamos a revitalizar para que vuelva a tener sus laderas libres y todo. No se puede porque ahí está la avenida Colombia y no se puede cambiar. La próxima, por favor. Entonces, lo que tenemos que hacer es tener adaptación de esas metas periódicamente, teniendo en cuenta, muy importante, a dónde queremos ir. ¿Qué significa resiliencia? Definición periódica de los caudales peligrosos. Melissa nos estaba mostrando ese proyecto que están haciendo ellos, que se hace en toda Alemania, pero ya lo hace especialmente para esos dos estados. Y se trabaja con caudales que se definen como el caudal que puede aparecer una vez cada 100 años o una vez cada 1000 años. Pero el caudal que puede llegar aparecer cada 100 años, ese caudal nos está apareciendo cada 10 años. Entonces, toca volver a decir, en metros cúbicos, ¿estamos bien con ese proyecto? ¿Nos va a caber el agua en un futuro? ¿Sí? ¿O no nos va a caber el agua? Porque los datos que teníamos antes del cambio climático nos decían, si hacemos los cálculos con los datos viejos, si protegemos para un caudal de que aparece cada 100 años, estamos muy bien protegidos. En Baviera se protege ahora cuando se hacen construcciones también así de poldas y eso, se está protegiendo para un caudal de cada 100 años más 15%. 15% es por decir, tengamos en cuenta un cambio climático que no sabemos cuál va a ser. ¿Sí? Entonces, por eso la adaptación de los caudales peligrosos, ¿qué es eso? Adaptación y descripción de las zonas inundables también. Si yo cambio los caudales, todo el proyecto de Melissa también va a tocar adaptarlo. ¿Serán suficientes esos retenedores? ¿Serán suficientes los diques que voy a hacer? También necesitamos protección de las áreas urbanizadas y protección y planeación inteligente de las urbanizaciones nuevas, como decía Jan-Olof. Claro que la planeación inteligente de urbanizaciones nuevas es importantísima, porque todo lo que yo tengo la oportunidad hoy de planear, puedo hacerlo de tal forma que yo degenere tan poco como posible el sistema natural y el sistema de las aguas, de tal forma que entonces no tengo que cambiar más adelante haciendo solamente protección activa de las zonas urbanizadas. La próxima, por favor. Entonces, esta lámina nos muestra, digamos, qué quiere decir, qué es lo que tratamos de hacer. No tengo la mouse ahorita, claro, no puedo, pero es un círculo vicioso prácticamente. Yo estaba en la revitalización del río, en la lámina de arriba, los ríos canalizados, y esta lámina es de la Directiva Marco Europea, y entonces dice, primero tengo el río, ¿y qué quiero? ¿A dónde quiero llegar? No puedo llegar a que el río pueda ser como en la época de los dinosaurios, o la época antes de Cristo, ni idea, ¿no? Cualquier época que yo diga, ese sería mi resiliencia, mi meta. Entonces, primero miro cómo está el río en la parte de arriba de la izquierda de la lámina, donde están las dos personas tomando pruebas de agua, pruebas químicas, hay peces, qué invertebrados hay, todo eso, ¿no? Y después yo miro a un análisis y digo, ¿qué me ha causado esos impactos? O sea, tengo impactos en el río, después miro, ¿qué me ha causado esos impactos? Conociendo las presiones, que son las que causaron los impactos, puedo decir, ¿qué puedo hacer? ¿Qué puedo hacer? ¿Qué cambios puedo hacer al sistema para ayudarle a ser resistente y que se pueda volver a regenerar hasta un punto determinado? No en la mitad como la ranita que se paró en la mitad, sino a la izquierda o a la derecha. ¿Cuánto tengo que hacer? En este caso dijeron, tenemos pocos peces, hagamos una escalera para peces que la ven abajo a la izquierda. ¿Sí? Y 6 años más tarde hay que mirar si eso es suficiente. Se vuelve a mirar cuáles son los impactos causados. Todavía no tengo peces o ya llegué al buen estado ecológico, entonces voy por buen camino. ¿Sí? Pero podría ser que también esos métodos no funcionen, que el pez no necesita solamente una escalera para subir de A a B o para llegar a la parte más alta del caudal. Entonces tengo que pensar nuevamente y corregir las metas y corregir también el punto donde quiero llegar. La próxima, por favor. El río Isar, como un ejemplo, de arriba a la izquierda está el río Isar canalizado en la ciudad de Múnich. No se ve la ciudad que está a la derecha y a la izquierda. Y las láminas de abajo muestran el río después de la recuperación. Les puedo decir que al final del año, ya los datos los tenemos, hemos logrado en 10 años llegar a un buen estado ecológico de este río. Significa, tenemos agua de calidad magnífica, la gente puede bañarse ahí y nadar, no tenemos químicos, no tenemos tóxicos, tenemos peces, tenemos aves, el sistema parece perfecto. Pero ¿qué nos trae el cambio climático? Mucha agua, torrentes, que de pronto nos destruyan los bancos de arena que tenemos, que de pronto nos destruyan toda la infraestructura y que de pronto el río no nos quepa ahí donde lo tenemos. O nos trae muy poca agua. Muy poca agua es peor. Muy poca agua significa en verano una incrementación de la temperatura del río. y una baja, y el río tendrá muy poquita agua, por donde de pronto no cabe la trucha, que es prácticamente el pez que aquí que es el que mide, el que nos da el estado ecológico. Entonces, si tengo muy bajo el nivel del agua, de pronto el pez no puede subir. Y si se sube la temperatura, la trucha dice, me voy a otro río, me voy para Suecia de pronto. Pero yo aquí no me quedo, aquí hace mucho calor. Entonces toca cambiar la meta. La meta ya no va a ser la trucha que siempre la vivo aquí, sino la meta va a ser otro pez que soporte la temperatura más alta. La próxima, por favor. Esto salió como raro. Bueno, no importa. Esto también era, no les quería mostrar, esto también era aquí un círculo a la derecha, que aquí no se ve como un círculo, pero pues no es tan grave. También es lo mismo, es un círculo vicioso, digamos, que dicen, si ven aquí a la derecha abajo, está el evento, la inundación, la catástrofe, la inundación o el torrente que llegó con la avalancha y se llevó todo el pueblo. Digamos, la inundación, el nevado del Ruiz, la avalancha del nevado del Ruiz. ¿Sí? Entonces, dice, después de la avalancha es antes de la avalancha. Después de la inundación es como antes de la inundación. Después de la inundación yo empiezo a recoger, a limpiar, a mirar qué pasó, a ayudar a la gente, empiezo a reconstruir, empiezo a proteger, empiezo a decir, las áreas que fueron dañadas completamente, esas tengo que dejarlas libres, ahí no puedo volver a construir. Entonces empiezo a pensar cómo puedo hacer, o sea, protección, como dice arriba, y después más hacia la derecha otra vez precaución. ¿Dónde están los bomberos? ¿Dónde está la policía? La gente, ¿sabe la gente que vive en una zona peligrosa? ¿Qué puedo hacer yo para protegerme yo mismo en mi casa? Y vuelve otra vez el evento. Y puedo otra vez volver a registrar en este círculo vicioso. Voy por el buen camino y encima de todo esto que es independiente del cambio climático, nos cae el cambio climático encima. O sea, la experiencia que ganamos sin cambio climático, tenemos que ponerle ahora el cambio climático, con más agua o con menos. Porque gestionar mucho es como gestionar, ¿qué digo yo? Si yo tengo 1 millón de pesos, pues los puedo gestionar, pero si no tengo nada, ¿qué voy a gestionar? Si no tengo agua, ¿qué es el problema más grande que voy a hacer? Si no tengo agua, se viene África completo para Europa, porque la gente se está muriendo de sed y de hambre. Entonces, el problema grandísimo del cambio climático y el que tenemos que adaptar los métodos no es tanto el agua, que la va a haber mucho, sino el no haber agua. Tengo otras, no sé si tengo más. No, pero eso podemos acortarlo porque de este tema ya nos habló Jan-Olof mucho. De pronto esta lámina que mostraba sencillamente que la construcción me hace perder, digamos, una forma de decir, la parte de la lámina de la izquierda me dice, si yo tengo un bosque y un prado naturales, tengo 40% de evaporación, tengo 10% de escorrentía superficial y 50% de infiltración. Y si lo construyo, tengo entonces, según esto, 15% de infiltración, 30% de evaporación, pero 55% de escorrentía urbana superficial, que me lleva a más torrentes en los ríos y que me lleva, claro, a mucho más a catástrofes en las ciudades mismas. Entonces, resiliente sería el sistema, digamos, en este caso, si yo logro construir la ciudad como nos estaba describiendo Jan-Olof, que dice, si yo construyo la ciudad de tal forma que el balance de las aguas, evaporación, escorrentía, infiltración, quede más o menos igual, no va a ser 100% exactamente perpendicular, o sea, el muñequito no nos va a quedar así, pero de pronto nos queda así WhatsApp y es mejor a que nos quede caído. La próxima. Yo creo que ya, si decíamos aquí que perdemos las zonas permeables y perdemos, espérate porque lo voy a decir en español, me toca cambiar aquí. Sí, la pérdida de zonas permeables en ese caso, y la pérdida de zonas de retención natural y la pérdida de cauces de escorrentía natural, importantísimo. Hemos cometido muchísimos errores en Europa porque tenemos escorrentía natural en las laderas, sin tener en cuenta, se ha cerrado todo como, digamos, Medellín más o menos, y ahí no cabe el agua, ¿no? Entonces, como decía Olof también, la planeación urbana inteligente es una de los retos que tenemos cómo lograr hacer una planeación urbana inteligente para el futuro y mover las urbanizaciones actuales. No sé si sea tan fácil meter árboles y zonas verdes a las ciudades grandes, pero eso es un reto. Y nosotros no les puedo decir cómo estamos cambiando, sino que tenemos todas esas ideas y sabemos que tenemos que cambiar las metas y tenemos que definir la resiliencia, pero no una vez, sino en periodos, cada 6 años, cada 4 años, cada 5 años. Hay que estar cambiando constantemente porque el cambio climático no va a parar en algún momento, sino que va a seguir constantemente. Eso es lo que les quería dejar como input. Muchas gracias.
Muchísimas gracias, señora Schulze. I think we have 1 or 2 questions from Sören right now, and then we see.
Yes. And I think this is particularly for Melissa. Melissa, and thank you very much, Dora, for this very interesting presentation. Melissa's clapping her hands as well. Melissa, if you could just switch on your webcam, because this one is for you. Jose wants to know, would it have been possible to minimize the material damage and human losses suffered by the Rhine floods last year? Was it inevitable? Were there inconvenience implementing preventive measures? Well,
yeah, I know what's that about. And I was supposing that someone would ask about that. Of course, it was a very big flood some weeks ago, and I want to answer this question. Well, in I'm also working very near to this zone, and we also already analyze why it happens. And I think I cannot say yes or not, but I want to say something. And like the conclusion of our analysis was that the means of communications are in charge of say there is a flood or not. Of course, it's impossible that you just said we are in a time that the television itself or the radio is the one who is saying, okay, there is a flood and the people will move, not only the firemen and etc. So it was not about the firemen. What I can say, there was, we knew that that was coming a flood, a big flood, around 2 weeks before. But these models that I was talking about, these hydraulic numerical models, are of course not 100% precise. And it's what Dora was talking about. Like, we are prepared for something that have been modeled based on statistics. And what happened nowadays is just out of the statistics of the last, I'm talking about 200 years statistics. So we knew it's coming a big flood, but the problem is that usually the models are predicting this sort of events frequently. So what said someone what was read in the newspapers? It is again coming hard rain and or a heavy rain. No? That's what we say in German would be Starkregen. No? And it's again like, oh, it's again coming a heavy rain. And of course, what if the people read that, it's like, yeah, okay, another one. And that was a big deal with this rain that was happening in July. I was also working a lot in that month. Because yeah, everyone knew that it's coming, but the people really, I mean, the whole system didn't move that much for that rain because no one thought it were going to be as the models say. Because many times happens that the models say that, but it doesn't happen. It's, I guess everyone knows this story of the, I think it was a fox and the sheeps or something like this. The wolf and the sheeps. And when you say, yeah, the wolf is coming, and then it comes and no one believed it because it was saying that. And that's what about decision making. No? It's like the government have to take into account, should I really said, okay, the flood is coming, even if it doesn't come?
Melissa, and do you now think that these recent events are taken into account into the new modelings? because you just basically said to us that because of the statistics, and the statistic used all the data which was collected before, and nowadays heavy rains and floods are being much more often and much more unpredicted. Are they adopting? Are you adopting these models?
Sure, Sören, it's a very hard question, and even not for me, but for the models itself, because even the mathematical part of the model is made not for heavy rain. The heavy rain have a very different hydrological movement, hydrological flow than a normal rain. I mean, Dora was saying in this impact picture, now you will have in maybe 3 hours the pluviosity that usually should be in 3 days. We are talking about that, and itself mathematically is absolutely another mathematical issue. And of course, not really. There are no models, for example, that not that I know, only for heavy rain.
Marco, I don't see any other question, but maybe if you have any other questions, or if you have any questions between you. You were citing a lot, Melissa, you were citing a lot Dora's talk, and Dora, you can also
I try to say it in English.
Very good.
It's not possible to prediction. No se puede predecir. It's not possible to say where is going to stay the cloud. It's not possible. Now it's not possible. And we can do anything. We can protection. It's not possible. It's not possible to protect the whole landscape. Even if it's not possible to think about nobody is going to have any water. So we are in it's not so easy. So we are thinking about, we are learning day for day, and we are learning from this event where Melissa was talking about. All people were warning in this iPhone, always saying it's going to rain a lot, but nobody could imagine that it's such a flood, and it was so long. It doesn't stop. So it's not, and it's very dangerous, because we are in Germany, we say, they call me and they say me what I have to do, what can I do, and all things which are allowed is possible, and all other things are reglementation or are regulated, but it's not possible. Now it's maybe like Melissa is mathematical, maybe she can have some some ideas where you can develop other things. But now we are thinking about what we take only 15% more water from the cubic meters per second. Yes, a little more than the normal, but it's only a number. But you can say where is going to stay the cloud. It's not possible.
Sören, I would say that this is
also
Melissa, what is Dora talking. I think it's a really should be an aim for everyone, not only for the policy, the decision making, not only for example, the universities, who are the ones who are developing these models, these numerical models, and not only for the private companies, who are the ones who are really like doing the projects or planning the projects.
Yes.
For example, if the city would be already adapted to heavy rain, so it might not happen that much, but it was even a, let's call it, tiny town. I mean, no one is thinking about doing these huge projects in that zone. So I think it's a challenge for everyone that no one is prepared, but it will be super interesting to work in.
Yes, it's a big challenge for the whole world. And then you have another things with exodus. How do you say exodus in English? Exodus from the people, because they don't have anything to drink and anything to eat. So it's moving all over the world. This is a big challenge.
If I might say a last sentence that is very important for me, it's born in my heart now. I've been in many conferences and I really realized how much potential is in South America and in Africa. Because we are talking about that in Europe, everything is done and everyone have money and everyone have knowledge. But we in South America, we are the ones who know how to react when there is this sort of events. And for example, in Colombia, there is such an advance in that topics. They really know how to react when there are, I don't know, volcano eruptions or floodings or etc. Why? Because they have it every year. In Europe, it's happening every thousands of years.
Yes. Yes.
Yeah, thank you, Melissa. And I think you built a very nice bridge to the last question. And I want to include Mr. Drangert here, as well. What challenges do you see in Latin America regarding the state water offices in Latin American cities regarding flood prevention? Jan-Olof, maybe you could elaborate a little bit on that, and then we close our panel. I think your microphone is still muted. Yeah, Jan-Olof, your microphone is still muted. I think you have to open your microphone. It's still muted?
There we are.
Yes.
Now it is working. Perfect.
I think that it differs a lot. I mean, in Cali, it's so hilly, and it's very difficult to find places to retard the flows and flash floods. So that differs totally from the example you gave from Rhine, where it's flatland and you can really make polders all over the place if you can get access to the land itself. So, and I have a feeling that at least in urban areas like in Bogota or Cali or some other places, the geography is complicating things quite a bit. And maybe you have to tunnel it or whatever in order to get rid of the worst floods. I mean, in Stockholm, although it's fairly flat here, we built a huge underground, it's a huge volume which we blown up out of the stone there. And it can take almost 2 days of rain in that one. So in that way, we try to slow down the water flow, and have been quite successful in doing that, but it's terribly expensive. So I think that money also counts when it comes to the solutions. You have to eat what you can afford.
Yeah, thank you. And back to Marco, and I think this was a very nice last sentence.
Yes, thank you all. I want to invite you at the end that we have a networking session right now. 1.5 hours, you have now time to make your own networking sessions. You can apply in Hupilo. If you take a look who is there as a participant, you can ask them to have a networking session. And in 1.5 hours, the program, the agenda will further. So thank you all again, Dora, Melissa, and Jan-Olof. And vielen Dank, Sören. Thanks for the support. And I hope you had a good session right now in the environmental part of today. Everybody is invited to start in 1.5 hours further. And tomorrow you have again another day of the AVAPA Summit. So thank you from here. Thank you from Germany. Sören from Sao Paulo, and the others, I think, in Germany and Sweden.
Yes. Yes.
Thank you.
Bye.
Thank
Thank you
you.
very much.
Have a nice afternoon.
And
Thank you
Thank you very
all.
much, Aura, for everything. Bye.
Bye-bye.